Hello, 8th graders. Mr. Lawrence here in another review video. We're going to go over some surface area and volume kind of things today. I know a lot of you struggle with this, but it's really simple stuff. Just ask the pre-algebra kids. They've gotten pretty good at it. All right. Well, first of all, we're going to take a basic shape like a prism, and we're going to do the volume. Okay. The volume of a prism can be found by just doing the area of the base, capital B, and multiplying by the height. Now remember, the base is not the side it's sitting on. The base always makes uh, a right angle with the height of the shape, right? So in this case, my base is a rectangle. And my base, I'm going to do lowercase b times height. That's the height of the rectangle, not talking about the whole cube. And then I'm going to multiply by the height of the actual prism. Well, the height of the actual prism will be what? 12 feet. And I don't know if you can see the rectangle. This one here is 30 feet by 4 feet. And so it doesn't matter which one you call the base and which one you call the height of that rectangle. And so you can do 30 feet times 4 feet. And so I'm going to do 3 times 4 is 12, and 12 times 12 is gross, 144. But it was really 30 times 4, so it'll be 1,444. And feet times feet times feet is going to be feet cubed. And so there is the volume of my prism. Okay, pretty simple stuff. Now, by the way, you might have to do a composite shape sometimes, something that looks like this, or you would have, a prism, but it looks like, a prism stacked on top of a prism, something along those lines. Okay, if I were going to do a problem like that, I would just break it up into two prisms. And I would figure out the volume of this top one and then do the volume of the bottom one and then add them together. All right, how am I going to do surface area? Well, I've got to ask myself, what is this prism made up of? It looks like all rectangles. And there's different types of rectangles. In fact, I see a 30 by 40 rectangle. And so there's a 30 by 40, oh, by 4, excuse me. But there's actually two of those, aren't there? Wouldn't one of them be here on the top? And wouldn't the other one be on the bottom, the side it's sitting on? So 4 times 30 ends up being 120. And multiplying by 2, because there's two of them, it'd be 240 feet squared. Now I'm not done, because there's other rectangles. I see a 12 by 4 rectangle. 12 by 4, that would be like this side here. But wouldn't it also be over on this other side? So we're going to get 12 by 4, which is 48. But then we're going to multiply by 2. Why? Because there's two of them. All right, so that's going to be 96 feet squared. And then finally, there's one more pair of rectangles. I'll do this one in red. And I think that's going to be the 30 by 12. 30 by 12. And that'll be 36 with a 0 on the end. There's two of them. That would be the front and back. See, I would call this a 30 by 12. But then there's one on the back side as well. Okay, so we'll multiply by 2, and that'll be 720 feet squared. And so I'm going to add all these together, and it looks like it's going to end in 6. I'm going to have a 4 and 11, 5, carry the 1, a 7 and 2 is 9, the 1 carry, 1,056 feet squared. Okay, that's your surface area. If I had this composite shape, I would do much the same thing. I'd break it down into rectangles. All right, let's check out this one, a pyramid. And you're going to go, that doesn't look right. Well, it's a pyramid with a rectangular base. Pyramids don't have to have square bases. They can have pentagonal bases. They could have triangular bases, hexagonal bases. Well, this one has a rectangular base. I'm going to do the volume and the surface area of it as well. For the volume of a pyramid, I'm going to do the area of the base. In this case, it's a rectangle. Multiply by the height. But I'm going to divide by 3. Remember, in my pre-algebra class, you guys did the third of a cube activity. You made 3 pyramids, and you put them together, and they made a perfect cube. So you got to remember to divide by 3. Okay, now in this case, I know capital B is a rectangle. And I know the area, I know to find the area of a rectangle. I like to use the base of the rectangle times the height of the rectangle. So I'm going to set up, let's see here, the base of the rectangle could be 16 inches. The height of the rectangle would be 10 inches. Now the other h is for the height of the pyramid, that's 15. And then I have to divide by 3. Okay, I know that's going to go in there once. It's going to go 5. 16 times 5 is 80, and 80 times 10 should be 800 inches cubed, because these are both inches as well. All right, there's my volume. Now to do surface area, obviously I'm going to have a rectangle, and that's going to be 16 times 10. There's only one of those. That's 160. I need the 160 inches squared. I'm going to put that over there. But I've got some triangles going on, and this gets just a little bit tricky. Okay, I think I'm going to have to do the Pythagorean theorem twice on this one. You see, to find the area of the triangles, I'm going to need the height of the triangles, and it's going to change. This one here, do you see the right triangle that I'm making? This triangle here is 15 by 8, and I'm going to have to figure out x, the slant height of that triangle. So I'm going to have to figure that out, and I'm not going to do all the work. I am going to tell you I'm going to do the Pythagorean theorem, and I know this is 10, and when I get the height of that triangle, it's going to be 17. Okay, and there's going to be two of those. One is going to be on the left side of the pyramid, one's going to be on the right side. Now, if the base were a square, I wouldn't have to do this much work. So I'm going to do 10 times 17, and I'm going to divide by 2. 5 times 17 is 85, and then when I double, because there's two of them, I'm going to be back up to 170. So now I have 170 inches squared. Okay, but there are two other triangles. Yeah, and they're hard to see. They're going to be the front and back triangles. And in that case, sorry, I wanted to grab that. It's going to be this triangle here, and it's really hard to see. But I'm going to draw it, and I'll draw it in red. Okay, got a triangle. I know that this is going to be 16. What I don't know is this. Well, I can find that by using 15. Oops, do I have a mistake? Yeah, I think I do. Yeah, I do have a mistake. Let me back up here. Okay, let me finish this one and I'll fix my mistake. Okay, this is going to be all 5. Oh no, I'm good. I'm good. I don't have a mistake. Okay, so now I got to use the Pythagorean theorem to get that. So I'm going to do 15 squared, the square root of 15 squared plus 5 squared. And that'll get me about 15.8. So that 15.8 is right here. 15.8. So I'm going to do 16 times 15.8, but then I'm going to divide by 2, and then finally I'm going to multiply by 2 because there's two of them. Now some of you are going, hey, Mr. Lawrence, can these two just cancel? They sure can. If you want to do it that way, you go ahead. All right, so I'm going to get finally a 252 inches squared, 0.98, I think. Okay, and so I'm going to add those together. 252.98 plus 160 plus 170, and that's going to be 582.98 inches squared, and there is my surface area. Okay, one more. We're going to do a cylinder. Now, by the way, I do want to point out to you that remember that on a cone or on a pyramid, we had to do a third divide by 3 for the volume. Same is true of a cone. A cylinder has the same relationship as a cone, as a pyramid does to a cube. So if I was looking for the volume of a cone, I would pretend it was, I would do the volume of a cylinder and divide by 3. Okay, enough about that. You'll have to do that on the worksheet, but the volume is going to be the area of the base multiplied by how tall. Well, the base is a circle, and to find the area of a circle, I need to use pi r squared. Just remember what shape pi r squared. Okay, but I need the radius, and this one didn't give me the radius, it gave me the diameter. The radius is 50, excuse me, the diameter is 50, the radius would only be 25. So for the area of the base, I'm going to use 3.14 for pi, and then I'm going to put 25 squared in there. Now the height of it is 100 of the whole cylinder. So I'll go ahead and crunch that on my calculator. 3.14 times 25 squared times 100, and I'm going to get 196,250, and that'll be millimeters cubed. Okay, now to do surface area is just a little bit trickier. Two parts are easy because there's two circles, and we know the circle has a radius of 25, and so for this one you're going to do pi r squared. In other words, 3.14 times 25 squared, and then we're going to multiply that by 2 because there's two circles. The part that's a little tricky is the body of the cylinder. Well, I bet you don't realize this. The body of the cylinder is actually a rectangle in disguise. Where's my rectangles? Rectangles. There's a rectangle. Okay. Now, the one side of the rectangle is easy. That's the height of the cylinder. And what did I have? 100, I think? Yeah. So that's 100 millimeters. Okay. Now this side of the rectangle is actually the distance around the rectangle. And the distance around is their circumference. And the circumference is found by pi times the diameter. So to do this side, I'm going to do 3.14, and I'm going to multiply by 50. Okay, so I'm going to do 3.14 times 50 times 100. And that ends up with 15,700 millimeters squared. So I've got 15700 millimeters squared. And then the area of my circles I didn't do yet, 3.14 times 25 squared. And there's two of them. And so I end up with 3,925. 3,925 millimeters squared. And in case you can't see the square on that one there. Okay, and I'm going to add together. And when I, what is going on? Okay, when I add together, I'm going to get 52691, 19,625 millimeters squared, and that is the surface area of the cylinder. All right, that's it for the lesson. Mr. Lawrence signing off. Good night, everybody.